welcome again. Still now, we have completed up to Bohr's atomic model, then excitation energy, ionization energy, then after energy level diagram. So today, the last concept of atomic physics, that is hydrogen spectrum and spectral series. So let's start. Hydrogen spectrum. Hydrogen spectrum. So student, remember one thing, spectrum. Spectrum means it's a range of frequency. When you go to higher classes, you will know about this spectrum. We are completely surrounded by number of spectrum. Remember, when we are operating some mobiles, each mobile are operating in a definite range of frequency. That is called its spectrum. Each area is divided with some spectrum. So spectrum means range of frequency. And what about hydrogen spectrum? So let's draw a structure of atom. Suppose this is your nucleus. This is the first orbit. This is the second orbit. This is the third orbit. This is the fourth orbit. Okay. So what we know, when electron absorbs energy, it jumps from any ground state orbit to higher orbit known as excited state orbit. Okay. If the excited atom returns to its normal state or ground state, then after the absorbed energy which is absorbed earlier is released in the form of energy, that is radiation. This means the radiated energy is released in the form of radiations. Okay, so there is a power cut over here, so the light will be a little bit darker. We can continue this. Okay, so what I say, when electron jump from any higher orbit to ground state orbit may be first orbit, maybe second orbit, maybe third orbit, like this. Okay, at that moment energy released in the form of radiation. But it depends whether the electron is jumping from orbit number 3 to orbit number 1, or orbit number 3 to orbit number 2, or orbit number 4 to orbit number 1, or orbit number 4 to orbit number 3 or 2. In this way, the radiated energy will have different wavelength. Clear? And if we see all these radiations with the help of spectroscope, we will find a thin vertical lines known as spectral lines, like this. Suppose electron is jumping from orbit number 4 to orbit number 1, or the orbit number 1, 2, 3, 4, 5 to orbit number 1. This is spectral line. Okay, and now I am doing what? I am fixing my orbit number 1. Fixing my orbit number 1 is my ground state orbit. Okay, clear? Then radiation from excited orbit 4 to 1, 3 to 1, 2 to 1. It will create a range of series of spectral lines. Okay, this is called spectral series, and this series is given with some name. This is my Lyman series. This is my Lyman series. Clear? Similarly, if I am fixing my ground state orbit to orbit number 2 with excited state orbit 5, 4, 3, 3. Okay, this is called to be balmer series. Clear? This is balmer series. Clear? Third, if I am making my ground state orbit to orbit number 3, 1, 2, 3, this is called paschen series. Clear? If the grounded orbit is orbit number 4, this one, this is called bracket series. And finally, last one is paschen series, which can be shown if we are adding some extra orbit. Okay, so there are 5 spectral series. Okay, I am writing over here. First is Lyman series. For Lyman series, remember ground state orbit N1 is equal to 1 and excited state orbit N2 is equal to 2, 3, 4, 5, 6, dot 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 dot. Clear? Similarly, second one is balmer series. For balmer series, ground state orbit N1 is equal to 2 and excited state orbit N2 is equal to 3, 4, 5, 6, dot 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 dot. Then paschen series, then bracket, and last one is paschen. For paschen, N1 is 3, N2 is 4, 5, dot 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 dot. For bracket, N1 is 4, N2 is 5, 6, 7, dot 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 dot. And for paschen, N1 is 5 and N2 is 6, 7, 8, dot 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 dot. So there are 5 spectral series of which this hydrogen atom is made up of. Clear? So by using these value, we can find out the wavelength of the different series. Can you get that? What I said? By using these values, we can find out the wavelength of this different spectral series. Okay? How? We have the formula of wavelength, that is 1 by lambda is equal to R into 1 by N1 square minus 1 by N2 square. 1 by N1 square minus 1 by N2 square. Using this equation, we can find the different wavelength radiated when electron jump from any excited state orbit to ground state orbit. Okay, so let's find out. Before that, just copy this thing. Okay, so let's start Lyman series first. Okay, for Lyman series, remember this is the spectral series for which ground state orbit is always 1 and excited state orbit starts from 2, 3, 4 up to infinite. Okay, this is the definition of Lyman series. For Lyman series, the wavelength can be found out 1 by lambda is equal to R 1 by N1 square minus 1 by N2 square. Okay, Suppose n1 is 1 and n2 is 2. Then what is wavelength value? 1 by lambda starts from what? 2 to 1 is equal to r into 1 by 1 square minus 1 by 2 square. This equal to 4, I think this is 4, 3r by 4, 3r by 4. Then lambda 2 to 1 is equal to 4 by 3r. Okay, and this r is our Rydberg constant. I have already said to you, Rydberg constant, its value is 1.093 10 to the power 7 meter inverse. Okay, if you put this value over here, you can find out its lambda value. Okay, students. Similarly, we can find out wavelength for this series by taking the excited state orbit to infinite. Let's take this value 1 by lambda infinite to 1. Kete hobo? How much the value? R into 1 by 1 square minus 1 by infinite square, and this is 0. So this become what? This becomes r. Clear? So lambda infinite to 1 is 1 by r. Okay, so here you can find this is 4 by 3, this is 1 by 1 by r, this is 4 by 3r, this is 1 by 3r. So this value is higher value, this is lower value. Clear? So we can decide. So student, what I saw, lambda infinite to 1 is equal to 1 by r, lambda 2 to 1 is 4 by 3r. So within this range, all kind of radiation take place under Lyman series. Okay, so if you compare between these two values, this is my maximum wavelength and this is minimum wavelength. Within these two range, all kind of radiation take place with different wavelength. Okay, so in this, the spectrum releases is it is ultraviolet rays. Okay, so remember this Lyman series belong to ultraviolet rays. Here radiation spectrum belongs to ultraviolet region. Remember this ultraviolet region. Okay, clear? Next is balmer series. So the definition is very simple. Balmer series is the spectral series in which the ground state orbit is orbit number 2 and the excited state orbit will start from 3, 4, 5, 6 up to infinite. Clear? So for balmer series, let's calculate the wavelength, that is minimum wavelength and maximum wavelength. So minimum wavelength will create between two consecutive orbit, ground state orbit to first excited state orbit. Clear? So 1 by lambda maximum, that is for maximum value, n1 is 2, n2 is 3. So this becomes r 1 by 2 square minus 1 by 3 square. So this will r This is 4, this is 9, 36, 9 minus 4, this become 5r by 36, so lambda maximum become 36 by 5 r. Clear? Similarly, minimum 1 by lambda minimum is equal to r 1 by 2 square minus 1 by infinite square, because for this minimum value n1 become 2 and n2 become infinite. So 1 by infinite is equal to 0. So 1 by lambda minimum is r by 4, or lambda minimum is 4 by r. So this is the minimum value and this is the maximum value. Okay, and remember, for this series the radiated energy belongs to visible region. This means this maximum to minimum range of wavelength create visible light. That means Balmer series belongs to visible light. The radiation is visible light. So this is a very important short question. Radiation is visible light. So this series belongs to visible region or visible light. Okay, clear? I am erasing this, just copy it. We will start paschen series. Paschen series, the third series, paschen series. So paschen series is the type of spectrum series in which the ground state orbit is 3 and the excited state orbit starts from 4, 5, 6 up to infinite. Okay, so here is our paschen series. Remember, in paschen series the radiation spectrum belongs to infrared region. Okay, after which we will calculate about bracket P fund. These three series belongs to infrared region. Okay, so I am going to calculate about paschen series and I am giving you tasks to do the calculation for wavelength, bracket series and P fund series. Okay, so paschen series. So paschen series ground state orbit n1 is 3, excited state orbit n2 is 4, 5, 6, 7 dot up to infinite. Then the maximum wavelength and the minimum wavelength. So I am already said, or we have seen in last two cases means Balmer series and Lyman series, that to find out the maximum wavelength we need to take the consecutive orbit, that is ground state orbit and first excited state orbit. So 1 by lambda maximum is equal to r 1 by n1 is 3 square, n2 is 4 square, and this equal to r into 16 minus 9 by 144, and this equal to lambda max is equal to 144 by 7r. 144 by 7r. Similarly, minimum wavelength 1 by lambda minimum. This is n is equal to 3 and n2 is equal to infinite. R 1 by 3 square minus 1 by infinite square. This is 0. So this equal to 1 by lambda minimum is equal to r by 9. So lambda minimum is equal to 9 by r. So this is your 9 by r minimum wavelength. Within this two range of wavelength, all kind of emission take place in paschen series. Okay, so in paschen series the radiation spectrum belongs to infrared region. Radiation spectrum belongs to infrared region. Infrared. Also remember P fund and bracket, these two series also belongs to infrared region. Okay, so this much is for atomic physics, and this is the end of your atomic physics. And next class I will teach you all the problems. Okay, next 2 to 3 class we are going to deal with problem in atomic physics. Okay, thank you.